In this video, we're going to continue on with the mixed modeling here, the applications and just how to set them up. We have number 4, Sue likes to walk in a desert. She walks at 2 miles per hour in the desert and 4 miles per hour on roads. She wants to get to the parking lot as quickly as possible. She is 1 mile from the road and the parking lot is 2 miles down the road. Rather than walking straight toward her car, she will walk at an angle so that she reaches the road X miles from the parking lot. Express the total time t that Sue spends walking as a function of X and state its domain. So a couple things to think about here. We're doing this for future when you have optimization and you need to figure out, what's the best value for X for her to be, maybe most efficient with her time or in some way, shape, or form or that. And you can figure that out by just graphing these in Desmos, but we're just really working on kind of like hashing out problems, getting some problem solving skills, looking at different types of problems. This one is a distance problem. So we have distance equals rate times time. Okay, but we're looking at time t is what we want to have it all in terms of as a function of X. So we want to solve out for t here. So we would have t equals distance over rate is what we want to put our, our function in that, using that ratio distance to rate. So a couple other things to think of. We would have our total time would equal the time in the desert plus the time on the road. Okay. So we have to put the pieces together and figure out how long would she be walking through the desert and how long would she be walking on the road. So we're going to draw a little diagram here. And we have, let's say our road is here. And here's the parking lot. Okay, so here's my lot, or the lot she's trying to get to. We know that, let's see what else we're given, is the road is right here. The parking lot is 2 miles away. Okay. Here, Sue is starting here, and this would be 1 mile. Okay, so she's 1 mile from the road. And she could just go, she could just kind of go down and over, but that's going to be longer. Because she's going to be going slower through the desert. So through the desert, she's only going 2 miles per hour. So let's jot that down somewhere. So 2 miles per hour is her rate in the desert. So we'll call it rate desert. And then she's got 2 miles on the road, but she's going faster. So she's going 4 miles per hour on road. Okay. So we want to jot down those notes. And then, so maybe she can do a little cut through here, right? Kind of optimize and see, so she can kind of cut that corner, but she's going at a slower pace through the desert, but it'll still cut off some distance there. So that's going to help her out. But what would be the optimal point where she would, slant down, right? So that's kind of over. So that's what we're kind of looking at. And then to do that, to figure out what this, would be, we would need to use our Pythagorean theorem. So we could figure out that distance. We could call this distance here, we could call that x, some arbitrary distance x, okay? And then that would make this piece over here, kind of like the rectangle problem. This would be 2 minus x. And this would just be 1. All right. And so we're trying to find the total time. So if we could figure out the total time in terms of x, and we would have time in desert. So we know that would be distance over rate. Okay, time in desert. We'll call it, how about we call it T sub D? So T sub D would be the distance in the desert over the rate in the desert. Well, we know the rate in the desert is 2, but we don't know the distance in the desert, but we can figure it out in terms of x. That's what this would be right here. This would be our distance in the desert. So we could figure that piece out by using our Pythagorean theorem. So how we would do that is, I'll just put it off to the side over here, kind of similar to what we've done in other problems. So maybe pause the video and try that on your own. And then come back to it and fill in here. And then we want to add in the distance on the road over the rate on the road. So again, we know some of it. We know the rate on the road is 4, and the distance on the road we just are calling x. So that one's pretty easy. It's this piece that is a little bit trickier. Not too bad though. So go ahead and pause the video and figure that out using your Pythagorean. Okay, so I've done that work over here to figure out this distance. So by setting this little, these little pieces up and then trying to seek out what I need, what I have, and then what I need, that's how I figured out I need this piece. And I can then work out, oh, I could use the Pythagorean theorem. It's a triangle, okay? So kind of think in that term. So now we have our x squared, or square root of x squared minus 4x plus 5. It is nice if you kind of clean these up a little bit, but it's okay too. What I'm looking for is that you understand that you have two pieces, the time in the desert plus the time in the desert plus the time on the road kind of thing, and that you understand how to fit that together, and that it needs to be in terms of x, that you don't want to just leave it as d, because we don't want that. The question specifically says in terms of x. So this would be your answer for that one. And then the domain for that, again, the road is 2 miles long, so your x really can't go. It could be 1.5. It could even be like she could go all the way down and across on the road the full 2 miles, but it's not going to be 3, because x is this, only this piece right there. It maxes out at 2. It would be from where she starts over, but you don't include this y. That would be like the y component, so we wouldn't want to add that in. That's kind of a common thing that people often do. They just say, oh, it could go up to 3, but that wouldn't be the case because we're just looking at the horizontal there, the road. And so from where she's at to the lot is a distance of 2 miles on the horizontal. Okay, so I hope that helps. So we could say 0. Maybe she doesn't do any and she takes the full corner. That would be reasonable to say. That there's no cutting corners, and then all the way up to 2. Or actually, I said that a little backwards. That would be taking the full length of the road without cutting corners would be the 2, just to be clear. And 0 would be just going the full diagonal. She could do that and go all her time in the desert, but that's probably going to take her longer. And you could look at it in a graph, or you could, just kind of play with some numbers and put different things in for X and see how it works out, and which would be kind of give you a little idea of which is better or worse for that. All right, thanks for watching. We'll do the last one that is on the circular cylinder inscribed in a cone. We'll do that in a separate video.